Thank you everyone to join today's session. Welcome to today's technical webinar sessions. So I'm explaining you Autodesk Inventor Nastran, and I'm excited to be your host as we dive into the powerful capability of this advanced simulations tool. So let me introduce myself, Gaurav Patil. I'm working with Arkans India as a solutions consultant for the manufacturing, and I have more than 8 years of experience like CAD/CAM and CE. In today's sessions, we will explaining and explore how Inventor Nastran with it industry proven finite element analysis solver and can help engineer and designer perform accurate simulations to enhance product performance, reduce prototyping cost, and accelerate the design validation. So today's webinar topic is transform your engineering workflow with Autodesk Inventor Nastran. So we will cover key topics such as the basic of FEA and why it is crucial in product development, an overview of Autodesk Inventor Nastran capability, type of analysis like structure, thermal, and dynamic analysis, and best practice real-world applications. Whether you are new to simulations or looking to optimize your workflow, so this webinar will be provide valuable insight to enhance your design and analysis process. So stay tuned until the end of for the Q&A sessions, where we will address your query and discuss how you can implement Inventor Nastran in your project. So let's get started. So this will be the webinar agenda. So first of all, I will be introducing the Autodesk Inventor Nastran capability, and we will looking into the industry challenges they are facing currently and how Inventor Nastran can provide solutions on the challenges. And we will deep dive into the simulations type. And at the end of webinar, we have the Q&A session. So someone having any doubts during the webinar, so we will cover it at the end of webinar. Yeah, so Autodesk Inventor Nastran is a powerful embedded finite element analysis tools integrated into Autodesk Inventor. It designed for the engineering and analysts to simulate and validate design under the real world conditions with advanced simulations capability. Inventor Nastran support a wide range of engineering applications for simple linear statics analysis to complex dynamic simulations. So I'm playing the one video.
In costly recalls, or much worse. As engineers, you strive to minimize failure and build the best products for your customers. Simulation tools give you the insight to deliver safer, higher quality products to market faster at less cost. Now, with Autodesk Nastran in CAD, there is a better way to use advanced simulation. Your workflow is streamlined with Autodesk Nastran in CAD, which embeds the powerful FEA simulation capabilities of the Autodesk Nastran solver directly into Autodesk Inventor and other CAD systems. This seamless CAD integration gives you the immediate design guidance you need, even at the earliest stages. By preparing the simulation in CAD,
So there is a seamless integrations available in between the Nastran and Inventor software. So fully embedded within the Autodesk Inventor, allowing user to analyze design directly their CAD environments without importing and exporting model.
Stay connected to your model. There's no need to export or transfer to another system. Save time by rapidly exploring how your designs perform without recreating the setup for each iteration. Autodesk Nastran in CAD uses the industry-recognized Autodesk Nastran solver, trusted for its speed, accuracy, and verification. Rigorous validation using NAFEMS, the Autodesk Physical Testing Labs, and other published benchmarks ensure the accuracy you need for dependable results. Autodesk Nastran addresses a wide range of simulation types, including linear and nonlinear stress, dynamic response, steady state and transient heat transfer, thermal stress, fatigue, buckling, and composite laminate materials. To support these capabilities, Autodesk Nastran in CAD includes an extensive set of material models, including plastics, composites, and metals. The licensing system in Autodesk Nastran in CAD makes it easy to share the software across your team, even if they're using different CAD systems on different projects or in different locations. Autodesk Nastran in CAD is a key part of the Autodesk Mechanical Simulation product offering and provides you with additional workflow options. Like Inventor Professional, it's seamlessly embedded in CAD. But like Simulation Mechanical, it has advanced solvers for delivering highly complex simulations. Let's take a look at Autodesk Nastran in CAD in action. Starting in Inventor, click the Autodesk Nastran.
So there are multi-physics simulations is available and support a variety of simulations type, including the linear and non-linear stress, dynamic, heat transfer, and fatigue. So there are different types of simulations we can perform within the Inventor Nastran. So there are robust solvers like powerful by the industry trusted Nastran solver, so which provides the accurate and reliable result for the engineer simulations. Apart from that, there are different types of advanced material modeling libraries available. So include support for various material properties, including the isotropic, orthotropics, and nonlinear material, enabling the accurate representation of the complex behaviors. So this is a and you can see the Inventor Nastran interface is so user friendly. So intuitive, the tools and workflow designed to make setting up and running the simulations straightforward, even for users new to FEA.
ribbon. Apply your settings and run the simulation. Because Autodesk Nastran in CAD is integrated within Inventor, you stay with your CAD model. After the simulation finishes, view results directly on the model to see how it performs. Streamline your workflow. Make better design decisions by leveraging the speed, accuracy, and flexibility of Autodesk Nastran in CAD as a part of your design engineering process. Result in costly.
Yeah, so here common challenges industry facing while FE simulations. So model complexity. So this is the one of the major challenges industries facing. So accurate simulations require highly detailed models, which can lead to increase the computational cost and longer processing time. Even the material behaving representations is one of the major challenge industries facing. So capturing the complex material properties, especially for the nonlinear and time-independent and anisotropic material, remain a significant challenges. Boundary conditions and loadings, correctly defining boundary conditions and applied load is a crucial, as improper definitions can lead to inaccurate results. Mesh quality and conversion is one of the major challenges. So ensuring that the mesh is fine enough for the accuracy, but not so fine as to be computationally prohibitive, and ensuring the convergence can be delicate, balancing it. The computational resources demands high validity simulations require the extensive computational resources, making large scale simulation challenging for smaller team and organizations. And yeah, so and validation and verification is the most important challenges industry currently facing. So ensuring simulations accuracy through the validations against the experimental data and verifying the mesh independence can be time consuming and complex, especially for the innovative or first of its kind design. Yeah, so Autodesk digital prototyping is innovative way for you to explore your ideas before they are even built. It's a way for the team member to collaborate across discipline. It's a way for individual and companies of all size to get great product into the market faster than ever before. So from concept through the design, manufacturing, marketing, and beyond, Autodesk digital prototyping streamline the product development process from start to finish. So why do we need the FEA? So FEA adds the substantial value to the product design process. It provides a significant insight and design guidance that helps to create the better product. Some of the specific benefits and outcomes of using FEA include the following. Like you can see, the predict performance for the plan use, predict the potential failure and predictable abuse, evaluate and correct the observed failure, improper performance and safety of known as design, even improve the cost, weight of unknown design, develop the new and innovative concept, and modeling decision should be driven by the goal. So that's why we need the FEA for our product simulations. Yeah. So here you can see like finite elements, there you will get the multiple benefits. Like finite element analysis is a computerized system that can help engineer design product that are more reliable and perform better. FEA can help engineer like save time and money. Like FEA reduce the need for physical prototype and testing, which can save time and money. Improve product performance. FA can improve the performance with the help of engineer optimized design to meet performance and design requirements. Reduce wastage. FA can help engineer identify design failure and reduce the amount of material used. Predict how a product will respond. So FA can help engineer predict how a product will respond to different forces such as the heat, stress, and vibrations. Even FA can help engineer understand how a product will perform over time. And so there are evaluate different design. Even we can evaluate the different design through the softwares. So if we can help engineer to compare the different design and material choice. So there are huge benefits you will get through the finite element analysis. So Autodesk Nastran is a powerful simulations tool embedded within the CAD environments, enabling the engineer and designers to perform the advanced simulations. Switching between the software, it is powered by the robust Nastran solver, widely trusted in engineering field for the accurate and reliable simulation result. Even earlier we have seen in the video, so there are very good like integrations is available in between the Nastran and Inventor software. So user can directly switch their interface through the by clicking the only Nastran command, and they can directly go inside the simulation workspace, and they can perform all these simulations, whatever simulations they want as per the designing requirements. They can perform the simulations. So there are seamless integrations you will get in the software. Even huge types of simulations you can perform within this Inventor Nastran. So yeah. So I'm showcasing you the Inventor Nastran linear static stress, how we can perform in the software. So to create the linear static stress, we have to assign the boundary conditions. And then where you want to apply the load. So to create the linear static stress analysis in the Nastran, Inventor Nastran, so you need to follow some structure approach using the Nastran interface. So which provide you to the pre-processing, solving, and post-processing. Below it is simplified procedure for setting up and running linear static stress in the Nastran software. Once you assign the boundary conditions, then you can apply the load. And even here, I'm connecting the bolted. Here is a bolted connection, so that's why I'm assign the bolted connection here. Here you can see I just want to connect my sheet to another sheet. So that's why I'm using the contact command here. Okay. So here you can perform whether it is bonded, whether it is welded. So as per your requirements, you can assign the contact types. So it will consider in real words, and we will get the result as per the inputs, whatever inputs we have assigned in the software. So you will get the key benefits in Nastran static stress analysis, like seamless integrations with the CAD. The Nastran in CAD eliminate the need to export and import data between the separate CAD and CAE systems. So reducing the risk of error and increasing the efficiency and real-time feedback we will get. So engineer can see the effect of design changes on the structure integrity of their part in real time, enabling the faster iterations and design optimizations and easy of use. The user-friendly interface allow user to easily define loads, boundary conditions, and view results even if they don't have the deep background in a finite element analysis. Accurate simulations. Nastran solver is widely respected for its accuracy and robustness in solving complex structure problem and ensuring reliable result for linear static stress analysis and improve collaboration. Since the analysis takes place within the same CAD environments, team member can collaborate more effectively by sharing the same model and analysis result. Design optimizations engineer can quickly analyze multiple design alternative and adjust geometry to minimize weight and material using while ensuring that the design meet stress and deformations limit. So overall, Inventor Nastran's linear static stress analysis capabilities streamline the design process, improve product performance, and ensure that engineer can make data-driven decisions throughout the product lifecycle. Yeah, one more example I would like to showcase you in the video, like thermal analysis and heat transfer. So thermal analysis in Nastran is a crucial aspect of understanding how heat flow through the system and how temperatures variations affect the behavior of structures. These types of analysis help predict the performance of component in different thermal environments. So in Nastran, thermal analysis can be categorized into different like steady state and transient thermal analysis. So I'm just playing the video.
Welcome to this demonstration of using Autodesk Nastran in Inventor. During this video, we're going
So this is a you can see in the video. So this is a brake assembly. So we are performing the simulations on the brake pad. Okay.
going to discuss the benefits of using thermal heat transfer as well as the thermal expansion results to ensure the rotor on this brake assembly will not fail due to high stress concentrations. We'll focus on the rotor by itself and hide the other parts in the assembly. Autodesk Nastran is fully integrated in the Autodesk Inventor application. You will see the Nastran tab in the ribbon, as well as the FEA browser for easily setting up the study in the CAD environment. Let's begin by specifying linear steady-state heat transfer for the analysis type.
You can select the analysis type from the analysis tab.
The material properties can be taken right from the CAD model. The material contains both the conductivity and thermal expansion coefficient for both of the studies we will set up and run during this video. Next, we'll mesh the part or divide it into smaller pieces to be analyzed. For the first analysis, we'll apply the boundary conditions that simulate the heat flux generated from the friction between the brake pad and the rotor, as well as the rate this material releases heat into the surrounding air. All the faces need to be selected, except for the two faces that are coming in contact with the brake pad. We'll
Because here you can see there are two faces of the outside of the pad is outside of the disc. It's connected with the brake pad actually. So that's why we are deselecting those faces only.
put the outside temperature of 293 degrees Kelvin or 70 degrees Fahrenheit. Then the convection coefficient based on the material and ambient airflow. Next, we'll apply heat flux, or the amount of power per square millimeter for both sides of the rotor. All that is left is to run the solver. This model takes about 1 minute to solve. Let's take a look at the results for temperature. The plot that you are about to see will provide the non-uniform temperature distribution that can be used as a load in the thermal expansion study. You can see some of the heat is transferred to the vanes on the inside of the rotor. We can now set up the linear static study using these temperatures and also apply the torque load as the vehicle comes to.
Even we can apply the torque load.
Welcome to this demonstration of using Autodesk Nastran in Inventor. During this video, we're going to discuss the benefits of using thermal heat transfer as well as the thermal expansion results to ensure the rotor on this brake assembly will not fail due to high stress concentrations. We'll focus on the rotor by itself and hide the other parts in the assembly. Autodesk Nastran is fully integrated in the Autodesk Inventor application. You will see the Nastran tab in the ribbon, as well as the FEA browser for easily setting up the study in the CAD environment. Let's begin by specifying linear steady-state heat transfer for the analysis type. The material properties can be taken right from the CAD model.
So this is the approach when we are going to perform the analysis. So first thing we have to assign the material for the design, and then we have to apply the boundary conditions.
Material contains both the conductivity and thermal expansion coefficient for both of the studies we will set up and run during this video. Next, we'll mesh.
Then mesh is one of the best command we have to use here to distribute our load inequally on the component. So that's why we use the mesh condition here.
The part or divide it into smaller pieces to be analyzed. For the first analysis, we'll apply the boundary conditions that simulate the heat flux generated from the friction between the brake pad and the rotor, as well as the rate this material releases heat into the surrounding air. All the faces need to be selected, except for the two faces that are coming in contact with the brake pad. We'll input the outside temperature of 293 degrees Kelvin or 70 degrees Fahrenheit. Then the convection coefficient based on the material and ambient airflow. Next, we'll apply heat flux, or the amount of power per square millimeter for both sides of the rotor. All that is left is to run the solver. This model takes about 1 minute to solve. Let's take a look at the results for temperature. The plot that you are about to see will provide the non-uniform temperature distribution that can be used as a load in the thermal expansion study. You can see some of the heat is transferred to the vanes on the inside of the rotor. We can now set up the linear static study using these temperatures and also apply the torque load as the vehicle comes to a stop.
So we can analysis different bound like conditions as per the requirements. So here.
First, we need to hold the part down by fixing the holes where the rotor is fastened to the other parts in the brake assembly. We could use bolt connectors in this case if we included the hub in the analysis. Be sure to watch the video on bolt connectors to see how they work in Autodesk Nastran. Next, we'll apply the torque load on the rotor. We're going to apply the load on the 2 points in the center of the component. Before doing so, let's connect the points to the faces of the part using rigid body connectors. Notice there are 2 options for rigid body, such as interpolation and rigid. Interpolation works best for applied loads.
So we are applying here the connectors because our disk is connected with our the main wheel. Okay, so that's why we are
Rigid works
applying
well for prescribed displacements. Now we're ready to add the torque value to the 2 points. We'll apply an extreme load condition of 100 million Newton millimeters, or about 1 million inch-pounds, to both sides of the rotor. Subcases in the FEA browser are a great way to evaluate more than one scenario at a time and compare the results between them. Here we are going to select 3 of them. The first one that you see is analyzing the torque load alone. The second subcase will include the thermal load, which comes from the previous study results. When applying the load, you will see the option to select the result file that was created when the analysis was complete. The third subcase is the thermal load by itself without the torque. After copying and pasting the study, we'll simply delete the 2 load conditions that were copied over.
So here you can see we have used 3 subcases. For the first one is the structural load, and second one is the structural plus thermal load, and the third one is the thermal load. So
That's all we
there are
need to set up the
subcases we can create and get the result.
linear static study. We're going to use the same mesh from the thermal analysis. This analysis also takes about 1 minute to solve. Let's take a look at the results using temperature as the only load condition.
So now we can see the result in load conditions, how we will get the
Starting with the
result.
displacement plot, we're observing a deflection of 0.3 millimeters due to the thermal expansion. By showing an exaggerated deformation and animating it, we can
Even you can see the animated view of your simulation.
visually see how the rotor is moving. Next, we'll find out how that displacement is affecting the stresses in the model. We're seeing high stress in the arc between each fastener, as well as the areas behind the fastener. They are already beyond the yield strength of the material before the torque is applied. Next, we'll look at the stresses with the torque load only. We can see here the vanes on the inside of the rotor are absorbing some of the stress.
So here you can see there are some of the stresses happening. So even if you want to increase the quality of your product, so we can changes in the designing, okay, to improve the product quality.
Finally, let's look at the stresses caused by a combination of the torque load and the thermal expansion. We'll use the same maximum value for the legend as the previous plot, as well as the same visibility settings. Notice the stresses at every other extrusion for the bolts are higher due to the placement of the vanes. Perhaps by adding another vane in between, we can evenly distribute the stress. The changes that we make here in Inventor can be reanalyzed right inside the CAD design environment.
So you can directly switch your model from simulation workspace to designing workspace. Here, I'm going to add some few of the fins in the design to increase the strength of your part.
There is no need to send the model back and forth between systems. Here we'll simply open the rotor in its own window and change the number of vanes we would like to use.
So here we have added more wings here to increase the strongness of your part.
Then,
strength of
after
your
the
part.
study has been run, we can view the updated results for the new design.
And then you can perform.
Looking again at the thermal stress with torque, we can see that the extra vanes in between evenly distribute the stress at each of the extruded bosses for the fasteners. As you have seen, Autodesk Nastran in Inventor helped us to come up with a better rotor without leaving the CAD system. We can now confidently move on to innovation on other areas of the brake assembly.
So directly, if you want to change something in your design, so you can directly switch your workspace from Nastran to Inventor to edit something in your design to get the stressness or in your product. Okay, and then you can perform the simulations on your same component. So this is the beauty is available in the software. Yeah. So here you can see the basic analysis capabilities is available within the Inventor Nastran, like linear static analysis. So linear static analysis is one of the most common types of analysis. Determine the stress, strain, and deformations resulting from the applied static load and imposed constraints. So linear stress, strain, deflections, inertial relief, thermal stress and deflections. So pre-stress and mass properties, multi-axial fatigue, even the buckling, assess the stability under the load, examine the structure for sudden failure, modes caused by the comprehensive force. So critical load and mode shapes, linear and nonlinear initial stress. So pre-stress, static and normal modes. So enabling engineer to analyze structure subjected to initial stress and model the effect of initial stress state on the structure, displacement, stress, and modes. So normal modes like determine the undamped natural neutrals, modes, shapes, and frequency of structures, allowing designer to explore and resolve the problem within the noise and vibrations. Like linear steady state heat transfer using the principle of conduction and convection heat transfer. Engineer can examine design for equilibriums, temperature distributions. So yeah, you can perform the different types of analysis within the Inventor Nastran. Even if you are having some assemblies, so and modeling with the context, so go beyond the analysis individual part and real world simulations of assembly is possible, which is the sophisticated modeling of different kind of contact interactions, including slide, frictions, and welded contact types. So earlier we have seen in the video, like the assembly, how we can perform the simulations on the assembly parts. Even you can see the advanced analysis capability also included in the Inventor Nastrans, like non-linear static stress and non-linear steady state heat transfers, linear and non-linear transition response, random response. So analysis, random response means like analysis of the structure behavior in response to impositions of random dynamics load. Like frequency responses we can perform through the software, like determine the structure harmonic response based upon the frequency depends on the load. So here are so many automated impact analysis like AIA and drop test. Also we can perform through the software, like sophisticated treatment provide the realistic and meaningful impact and drop test simulations and only the input required and projectile velocity and accelerations. So there are so many advanced simulations available in the software. Yeah. So here the top 5 reason you need Inventor Nastran, like comprehensive multi-physics simulations. Like Autodesk Inventor Nastran supports a wide range of simulations type, including the linear, non-linear stress, thermal analysis, fatigue analysis, and dynamic simulations. This versatility allows the engineers to solve complex real-world problem within the single platform. Seamless integrations with the Inventor Nastran is the fully integrated into the Inventor software and enabling seamless workflow. So user can perform the simulations directly within the familiar CAD environments, reducing the need to transfer file between the software and minimize the error. Powered by the Nastran solver. So this is the software utilize the trusted Nastran solver and industry standard for the finite element analysis, like renowned for its accuracy and reliability. The solver delivered the precise result for the complex simulations, ensuring the confidence in the product performance. cost-effective solutions like Autodesk Inventor Nastran provides the high-end simulations capability at an accessible price points compared to other premium FEA tools. So this makes it a cost-effective choice for a small and medium-sized enterprise aiming to integrate advanced simulations into their design process. So scalability and flexibility, whether you are performing simple stress test or advanced nonlinear simulations, Inventor Nastran scales to meet your project requirements. Its flexibility ensures so it suits the need of wide range of industries, including the automotive, aerospace, and consumer products. So this is the features, and we can say like advanced simulations and features is available within the Inventor Nastran, and you will get so many benefits of that. Yeah, so yeah, I've done from my side. So if someone having any query and doubt, so please feel free to ask, and even you can drop your question in chat window. And please comment how was the webinar, and it will encourage and improve us to making upcoming webinar interesting and informative. Even you can note my mail ID if you are having any query, so you can drop me mail through the mail as well.
Or you can tell us how was the webinar was that an improvised session, an insightful session? You can tell us that as well.
We are planning to arrange one more so many webinar in the futures for the advanced simulations as well. So this is a short webinar actually. Okay, so in upcoming webinar, it may be more interesting and more informative for you. So it's depend on your inputs actually. So as per your inputs, we will plan to arrange one upcoming webinar. So if someone wants to like demo on the software, so we can arrange the demo as well. If you want to know the functionality of the software, so we can do that. Okay, but we need your input for that. And you have to reach out to us actually. If you want to explore something in the Inventor Nastran, so definitely you can reach out to us. Yeah, sure. So we will arrange the webinar as per the requirements like gravity and fatigue analysis. Sure. We will plan for that. So how was the webinar? So just we need your feedback on that. Okay, great. Okay, it was good. Okay. Okay, Nishan. So I think there is no any questions from the attendee. Yeah. So is there any full course available to learn these types of simulations? Yeah, so there are so many like there is training material is available on the Google. So Can you share your mail ID? So what I will do, I will share the link and you can go through that. So you'll get the entire detail through of the Inventor Nastran simulations. You just share me your mail ID here. So I will share the link of the full course actually. Okay. Nishant, you want to add something here?
So, first of all, thank you so much for amazing webinar, and we will be having some discussion in future as well for the same topic. And thank you all for joining us today. I hope you found the insights shared by Mr. Gaurav valuable, and n- you are now equipped with a better understanding of how Autodesk Inventor Nastran can enhance your design processes. And as we wrap up, I encourage you to explore the features discussed and consider how they can be applied to your projects. If you have any further question, please free to reach out to us. You already have my number and my email IDs, right? And we will connect again. Have a great day and happy designing. Thank you so much, everyone.
Yeah, thank you. Thank
Thank
you,
you so much,
everyone.
Gaurav.
Yeah, thank you, Nishant. Yeah, so can we close the session?
Yes, yes, we are ending.
Yeah,
Thanks.
yeah, thank you. Yeah, bye, bye, bye.